Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, I'll be talking about polynomial regression. In my previous videos, I have talked about simple linear regression, multiple linear regression. So in this video, I'll be talking about the polynomial regression. So let's get straight into it. So you can see it here. We have displayed the three different type of regression. The first one is simple linear regression, in which there is simple formula available y equal to b0 plus b1 x1. Then we got multiple linear regression, which I've already explained, that b0 plus b1 x1. It means we have a more than one independent variables available here. Right now, let's talk about the polynomial one. So what's the difference you're finding here? Instead of having different variables x1, x2, xn, we are having same variable, but the power is been changing. You can see it here, x1, x1 square, x1 cube, x1 4 times, right, 4 degree. Then we have x1n. So it means like we have basically we are using one variable, but we are using the different powers of that variable. So let's now have a look when you'll be using the polynomial regression, when it would become in handy. So you can see in this demonstration, in this case we have a set of observations available. All right, the lines that fits this data, it's always the simple linear regression, right? You can see it fit quite well. So let's see, for a change, let's say the data set look like something like this. In this case, you can see if we try to use simple linear regression, you can see you will see it that it doesn't fit quite well. So in the middle you've got some data underneath, right? Then as you go further data, it will be above the line. So how we can correct that? So well, we can try to correct that by using a polynomial regression. So let's have a look. So in this case, you can see instead of having a simple linear regression, we are going to conduct the polynomial regression, and that's in this case it fits perfectly. So what's the formula? So formula is, it's just almost the same formula, b0 plus b1 x1. Now we are having b2 x1 square. So this additional thing actually give us the parabolic effect, and so that the curve become parabolic and it fit the data better, right? So that's a change we are having. In the previous case, we were having if we are trying to use the simple linear regression, it doesn't fit quite well, but now because of this parabolic effect, the curve become parabolic and it fit the data better. So you can see, as you can see, the polynomial regression is bit different to as we compare with the simple linear regressions, and at the same time it has got its own use cases. So it's all come on case by case basis. So for example, you have a problem and you might try a simple linear regression or multiple linear regression. So with many variables, or you might try a polynomial linear regression. So see what happens, and sometimes the polynomial regression works better. So for example, they are used to describe how diseases spread, or how pandemics or epidemics spread across the territory or across the population. The polynomial regression can be handy there, and they also have their other use cases. So it's a matter of what works best. So it's always good to have more tools in your arsenal. So now we have one question left here, that why it is still called linear, right? So we saw that those different powers, square, cubes, power, and so on. So why it is so called linear? So if you look at on the left, it says polynomial linear regression. So well, the trick here is that when we talking about linear and non-linear, we're not actually talking about x variables, right? So even though they are non-linear, here the relationship between x and y is non-linear. So when you're talking about the class of regression, you're talking, so whether it's linear or non-linear, you're actually talking about the coefficients here. So interesting part, so whether or not this function which we have here, y is a function of x, right? So the question is, can this function be expressed as a linear combination of these coefficients? That because ultimately they are unknowns, these b0, b1 are unknowns, right? So the goal is, when you're building is to find these coefficients, find out their actual values, so that they further down the track you can use those coefficients to then plug in x and predict y, whether it's linear, a simple linear, multiple linear regression, or polynomial linear regression. That's a goal. So find these b coefficients. So that's why the linear non-linear refers to this coefficients. All right. So example of non-linear regression would be if the equation say like y equals b0 plus b1 x1 divided by b2 plus x2 or something, or maybe b naught divided by b1 plus x1. So situation where you really cannot replace the coefficients with other coefficients to turn that equation into a linear one. So in this regard, in regard to the coefficients, not that x values. So there you go. So that's why the polynomial regression is still called a linear regression. So we can also say that polynomial linear regression is actually a special case of multiple linear regression, rather than we can say it's a standalone absolutely new type of regression. I hope you must have understood the basics or the introduction to this polynomial regression. In the next video, I'll be talking about how we can implement this in our language. I hope you must be got all the points that I wanted to convey in this video. So see you in next video. Thanks for watching, guys.